All right, AP Stat, let's get this thing done. We're going to talk about 4.2 experiments. A lot of this stuff is going to be a lot of review, so we're going to move really quickly. All right, let me get this out of the way. Here we go. All right, this is the stuff we're going to do. I think mostly you can do this. There's just a couple vocabulary items that we're going to need to talk about, so we're going to work through this really, really fast. All right, an observational study, that's what we've been talking about, right? Go ahead and write this definition down. Know the difference between it. Most of you guys, your seniors, have already learned this stuff in your science classes. There you go. Okay, so this is a new thing, confounding. Confounding is going to occur, right, if two variables are associated in such a way that their effects on a response variable cannot be distinguished, right? So it could be a case that in your sample, say you're doing an experiment, and in your sample you have more females than males, and you're doing something that involves maybe talking about your feelings or something like that, right? Well, the females are going to be more likely to respond differently about talking about feelings than men, just because, in general, men don't do that as much as women do. So you would have to be careful, if you're going to be asking a question like that, to have an even sample of men and women, so that you don't have the confounding variable of a lot of women. Making that data non-realistic, right? Or making that be the variable. All right. So be careful when we're talking about experiments. The main difference is that we are imposing a treatment. And that's what makes an experiment, right? The difference between an experiment and an observational study. Okay, experimental units. They are the units that treatments are being applied to, right? When they're humans, we call them subjects. I told you guys about that. All right, so if you're doing an experiment on birds, your experimental units are the birds. You're doing an experiment on plants, experimental units are plants. If you're doing experiments on people, we call them subjects. In order to have a really good experiment, you're going to have to try to remove all of those other variables that could confound your experiment, right? And that's why proper sampling is very important, especially making sure that you have a stratified sample. All right, so another way to get rid of this confounding, right, is to have a control group and an experiment group. And that way you can see, hey, is the treatment the thing that's causing a difference? Or is it the subjects, right? And another way to, or the experimental units, differences in experimental units. We want to make sure that the differences in experimental units is not a variable that we're measuring. The variable that we want to measure is going to be the treatment that is occurring in the experiment. And that's the reason why we have a control group and an experimental group. Also, of course, we always need to randomly assign our subjects or experimental units to control or our experimental group, the group that's going to get our treatment, in order to not introduce any sort of bias. All right, so this is how this is going to work, especially when you all do yours, and then we need to talk about replication. We need to use enough experimental units in each group so that we're not seeing the differences, so that our results aren't being caused by differences in each of the experimental units, but our results are being caused by the treatment. Usually 30 is the minimum. So you want to have, at the very minimum, 30 experimental units in each of your control and in your experimental groups. That's the magic number in statistics for a sample size that is large enough. All right, here's a wonderful flow chart that shows you how to do this. All right, so in our completely randomized design, this is the way you're going to have to do your experiments. All right. These are also things that you're probably very familiar with. All right, the placebo effect and a double-blind experiment. Right, so a lot of times in a medical study, the doctor will be administering some sort of a medication, and neither the doctor nor the patient knows whether the patient is getting actual medication or a placebo. So they don't know whether the patient is in the control or in the experimental group. The whole thing that we're doing, the reason why we're doing this is we're leading up to doing inference. So we want to know if the difference between the experimental group and the control group is significant enough that it wouldn't have happened by chance. And we'll have some tools that we'll use in order to determine that later on, actually next semester, when we start to talk about inference and actually making these determinations based upon probability. We would love, if we were hoping for our hypothesis to be true, that there's enough of a difference in our experiment group from our control group to say that the results of our treatment were statistically significant. All right, so we would like to block an experiment, which is similar to stratifying your sample, right? So you have a group of experimental units that you know are similar, and you're going to go ahead and assign them to your experimental or your control group evenly, so that you don't have a large group of experimental units that are the same in one group and a large group of experimental units that are different, that have characteristics that are different. Right? We'd like to have a mixture of each of the two characteristics within our experimental and our control group. And similarly with the matched pairs design, we're going to take our experimental units and we're going to block them based on their similarity, right? And we're going to go through examples of how to actually work these things out during our next class. We're going to work some examples. We're going to actually simulate doing each one of these designs. All right, so that's it. I made it short and sweet because these are just the general ideas, and really where we put the rubber to the pavement is when we actually practice these things. So we'll be doing that on Monday, and you guys will really get a lot of experience with these different things and with your groups that are sharing as we design our own experiments. So thanks for watching, and take care, be safe, bye.